let us draw the layout of a 2-input OR gate from the twisted schematic. Now, open the terminal window by pressing Ctrl Alt and T. Type magic, press enter. Now this is the layout window. At first, we will draw the layout by using the commands. So type grid, then press Z. We have to draw the, since it's an OR gate, the NMOS is in parallel and the PMOS is in series. Since the PMOS is in series, it's a twisted diagram. So we will place a bigger anvil. Now type paint anvil. Now select the area for the P diffusion. Type paint pdiff. Now this is the two PMOS is in series. Now this is the NMOS. Paint and diff. The two NMOS are in parallel. Now first draw the two gates. So place the poly. Type paint poly. This is another poly. Let's undo. To place it over here. Then type paint poly. Similarly over here, type paint poly. After drawing the two gates, now this is the gate, this is the source, this is drain, this is again source, and this is drain terminal. So now the source is connected to VDD. Type paint M1. Paint M1. Now this is the VDD. Similarly, the two sources of the NMOS are connected to ground. So paint M1. Now the ground layer is done. Connect from here to here. Paint M1. As this is the source, this is source of 2 NMOS, and this is the VDD layer. Now this is the drain. The drain of the second PMOS is connected to the common drain of the NMOS. So select the area. Paint M1. Paint M1. Then connect from here to here. Now this is connected. This is VDD. Select, right click, label VDD, then label GND. This is input A. Label A. This is B. Label B. Now this output is A plus B bar. So I have to connect it to the inverter. Before that, I have to place the contacts. So first the P diffusion contact. Now this is the N diffusion contact. Similarly over here. Now after placing the diffusion contacts, we have to place the substrate contacts. Paint N substrate contact, that is NWC. Paint NWC. Similarly, we have to place the P substrate contacts. Paint PWC. Paint PWC. Okay. Now we need an inverter. select the area, paint anvil, then P-diffusion, paint P-diff, end. So now this is the NMOS and PMOS. So next you have to place the poly, okay. Now this is the input of the inverter. The source of the PMOS is connected to VDD. So paint M1. Similarly, the source of the NMOS is connected to ground. Paint M1. Okay. Now the drain of the inverter is shorted. So at first let's extend this. Now short these two drain terminals. Paint M1. This is so needed in order to place the contact. So paint M1. Now we have to place the contacts. So paint PDC, then type paint and DC. Now the output of the NOR will act as input of the inverter. Paint M1. Paint poly. Now since this is a metal and poly contact, so we have to place a poly contact. Now this output will act as input to the inverter and the obtained output will be Y. So now this is the whole layout of a 2-input OR gate. Let's save this. Save or 2 dot only auto, then extract all, extract to spice, then exit vi or 2 dot spice. So this is the P fits and the N fits. So there are 3 P fit and 3 N fit. This is the A input VDD. This is the area of diffusion, perimeter of diffusion. If I want to see my layout again, then type magic or 2 dot mag. So this is the layout of a 2-input OR gate. This is the final layout of a 2-input OR gate. If I want to check the syntax, I can type, if I want to see whether there are any DRC errors, there are no DRC errors. Now we will see how to draw the layout of a 2-input OR gate by using the toolbar in Magic. Press Ctrl Alt T to open the terminal window, then type Magic, press Enter. Now press G in the keyboard, Z to zoom in, go to Options, then Toolbar. Now we have to draw the layout for the 2-input OR gate where the PMOS is in series and NMOS is in parallel. Select the area for N1, Then middle click on the mouse. Then for the P diffusion layer, select the area and then middle click on the P diffusion. Then place the N diffusion layer. Select the area, middle click on the N diffusion. Now I have to make two poly. So this is one poly. Middle click on polysilicon. Now middle click on the polysilicon. Select the area and middle click on the N diffusion layer. Now when we're designing the OR gate, at first we design the NOR. So the source of the PMOS is connected to VDD. So middle click on the metal layer. Similarly, the ground, the source of the two NMOS is connected to ground. So now middle click. This is your ground. So ground and VDD. Let's label it. Type label VDD. Then label ground. Okay. Now this is the source and this is the source of one PMOS. This is so drain of this PMOS. This is the source. This is again the drain. So this drain is connected to the common drain of the NMOS. So select the area, then middle click, select the area and then middle click. Now so these two are connected now. Next you have to place the contacts. This is the P diffusion contact. let's place the P diffusion contact or PD contact. This is the PD contact. Now this is the N diffusion contact, ND contact, and this is also the N diffusion contact. This is the ND contact. I have to place the substrate contacts now. Select the area. This is the N substrate contact. So N substrate contact. N substrate contact. Similarly, the P substrate contacts. Okay. Now this is the NOR gate. Now we have to design the inverter. So select the area. Then select the N-well. Then select the area and now select the area and middle click on the P diffusion layer. We need almost equal length and breadth of the N diffusion as P diffusion, P diffusion as N diffusion. Now middle click on the P diffusion layer, N diffusion layer. This is N diffusion since this is a NMOS. This is P diffusion since this is a PMOS. Now we have to place only one poly. Okay. Now this is connected to VDD. And this is connected to ground. Okay. Now we have to place a contact. This is the P sub. This is the P diffusion contact. Okay. Before going for the contacts, we have to connect these two drain terminals. Okay. Now we can place the contacts. Select the area, PD contact. PD contact, then the N diffusion contact. This is the N diffusion contact. Now, after placing the contacts, we can see this is the input A. This is input A. Let's label it as A. Label A. This is label B. Label A, the label B. The output is A plus B bar, which has to act as the input to the inverter. This is the metal layer, and this is the poly layer, polysilicon. Now select the area, and middle click on the PD contact. Now we have to label this as Y. Now right now our layout is not saved, so type save or 3, extract all, then extract to spice. Now exit vi or 3 dot spice. So you can see our scale is 1 1U. This is the MOSFETs, PFETs. PFETs are of all PFET and NFET, they are of equal W by L ratio. You can see the value of C and the corresponding area of diffusions and perimeter of diffusion. If I want to check my layout, I'll type magic or 3.mag. .mag is the extension of the magic file. Okay, it was comma, so this is dot. This is the layout of a 2-input OR gate. That's gridden. So this is the final layout of a 2-input OR gate. Now we will see the layout of a 2-input OR gate from the normal schematic diagram. Open the terminal window by pressing Ctrl Alt T. Type magic, then press enter. Now this is the layout window. Type grid. Let's zoom in. When we say the untwisted form, then it has got a series PMOS. So this is a series PMOS. type paint anvil, then paint P diffusion, the the PMOS is in series, but the NMOS is in parallel. So type paint NDiff, this is the N diffusion layer. Paint and diffusion. Okay, these NMOS are in parallel. Now place the poly layer. I have to draw the poly layer in order to create the gate terminal. Paint poly. Now the poly layer for the NMOS. So I have to short these two. So let's erase this part. Connect from here to here. Paint poly. Now this is one input. We'll paint the second input. Paint poly. Now select this area and erase. Okay, now these two are shorted, these two are shorted. This is connected to VDD. So type paint M1. The source terminal of one PMOS is connected to VDD. The drain and source are shorted. Then the other terminal is, these two drains are connected. So type paint M1. These two drains are connected. Now this is connected to VDD. These three are shorted. Now the sources of these two are connected to ground. Paint M1. Paint M1. Erase. Now these two are connected to ground. This is ground. So type paint M1. Okay, now this is the VDD. So select the area, type paint P diffusion contact, P diffusion contact. It's very important to place the contacts. So now this is the end diffusion layer. So paint end diffusion contact, paint end diffusion contact. Okay, we'll place the substrate contacts later on. We'll place the substrate contacts later on. Now this output, this is the input. Let's write the inputs. Label A, label B, label VDD, label GND. Okay, now this output will act as input to the inverter. So we have to design the inverter now. Type paint anvil, paint P diffusion, then of the same length type N diffusion, this should be of more longer length, the breadth should be more, so paint N paint P diffusion, type paint and diffusion. Okay, now we need the poly contacts. Paint poly, now remove this part, erase. Okay, now connect these two poly. Okay, now these two are connected. The two gates of the inverter are connected. This is connected to paint M1. Paint M1. Now this is VDD and ground. Now these two are also shorted. Okay. Paint PDC. Paint PDC. Paint and diffusion contact. Okay. Now this is the inverter portion and this is the NOR portion. Before that, we also have to place contacts over here. So paint PWC, the P substrate contact. Paint PWC. P WC. Now this is the N substrate contact. So type paint NWC, paint NWC. We can place as many as contacts as we want. Okay. Now this input will act as this output will act as input to the inverter. So type paint M1, paint poly, then select this area, paint poly contact. Okay, now this metal and this are connected, and this is the output of the inverter, which is the output of the NOR gate. Label Y. So now this is the whole layout. Save or 4. Unknown command save or 4. Okay. Save or 4. So there were some errors. Now if I type save, okay, extract all, extract to spice, exit vi or 4.spice, magic or 4.meg. Now we will draw the layout of a two-input OR gate by using the cell instantiation process. So open the terminal window by pressing Ctrl Alt and T. Type magic. Now type grid. Zoom in. By the help of cell instantiation refers to that we will use a two-input NOR gate, then we'll place a NOT gate in order to obtain OR gate. So type get cell NOR4. Since earlier we had drawn NOR4, zoom out. In order to see the content, select the area, then press X. So you can see this is a two-input NOR gate, the layout of a two-input NOR gate. Now we will use a inverter over here. Select the area, type paint anvil. Select the area, type paint, pdiff, then type paint ndiff, type paint polysilicon. Now this is the inverter where we have to attach, we have to connect the source to VDD. Type paint M1, then paint M1. Now connect from here to ground, from here to VDD. Paint M1. Okay. Now these are the drain terminals which are shorted. Paint M1. Okay, now place a contact over here. The contact is paint, P diffusion contact. Paint a P diffusion contact. Similarly, N diffusion contact. then paint PWC, paint NWC. Now this is the input, this is the output. So connect from here to here. Type paint M1, paint poly. Now this is overlapping between metal and poly layer. So select the area, type paint poly contact. Now this is the obtained output, that is Y. So label it as Y and save, or 4, save or 4, extract all. So you can see NOR4 has been extracted and also OR4. Now extract to spice, exit, vi OR4 dot spice. So you can see, since we have instantiated NOR4, it's written as NOR4 underscore 0 slash a underscore n2. Similarly over here also NOR4, here also NOR4, NOR4. Since we have used instantiation, it's showing NOR4 everywhere. If I want to see my layout again, type magic or 4.meg. It's meg, not amg. So you can see this is the cell instantiated one, and this part is the inverter. So if I select, press X, then I can see the whole layout.